I have such a nice home.
Oh, and I'm sure, but wait, is the video starting? Of course it is. Oh yeah, right. Sorry. Hi everybody. My name is.
Anyway, sorry.
It's okay. Hi, my name is Flopsy, and welcome to Math Explained. Hi, I am Flowery, and welcome to Math Explained. Get out of the way. I'm gonna be teaching here, because
Vicky got a bit too violent. Wait, it was Vicky.
Can you do this to me, your mother? It's okay. Her daughter's still okay, right? Yeah. But it turns out her daughter is mad. Get out. I'm not sorry.
Let's just start.
Okay, fine. Jeez. Let's check to see if there are any fallen babies. Oh, there's a baby.
If there are any fallen babies.
There's a fallen baby.
That's not a baby, that's a boo.
I know, and he's pretending to be a baby.
Wow, something this terrible would happen if Boo was scared, but I'm sure he's imagining things. There's nothing threatening around here.
And I thought I was the only one that got scared by Boo. Sorry. Okay. No time to distract yourselves. It's time to really get started here. So, I'll be teaching here. You guys can't just start conflicts with each other. I'm sorry. We're very sorry. We just want to teach here. I know. But don't worry, you're going to teach later. Hooray! Just not right now.
Just.
We're starting! Anyways, hi, I'm Amor, and welcome to Math Expressions. Are you done crying now? You're in the playtime area. The playtime area is what you love.
Okay. I think I'm done now.
Stepping stones are so hard to walk out of. Okay, I walked out of them. Anyways,
I'm done. I'm in my house and I'm enjoying the playtime area.
Okay. Hi. We are going to be learning. Hi, my name is Amor, and today we are going to learn about 2D and 3D shapes. What are those shapes? That's a very great question, Rosie. 2D and 3D shapes are actually one of those familiar shapes that we see pretty much almost everywhere, really. Shapes are found almost everywhere. It's almost everywhere, but not everywhere. Like, this isn't a shape, obviously. So, shapes can be found almost everywhere on Earth. Almost everywhere. So, but most places. Look at each shape, write the number of straight sides. I think you guys should know what a shape is, right? No. Well, I'm going to teach it to you again. A shape is a geometrical figure that has straight sides and angles.
What's that?
What? Or it's simply just an abstract figure in math. Oh, okay.
What's math?
You're kidding, right? We have gone over math in nearly...
Okay, I get it.
In nearly over 50 videos. 50 videos, okay. And you still don't know what math is.
I get it.
Oh, you sure you've got it?
Yes, I got it.
Okay. You're not going to ask that question again.
Nope. Well, maybe not in this video.
Okay, anyways. So, identifying how many straight sides a shape has is very simple. You just look at how many sides it has overall, if it has any. So,
What if it doesn't have any?
well, then it's a circle.
Okay.
So, let's look at this shape here. What do you notice about this shape? Ooh, 1, 2, 3, 4. It has 4 sides. That's right, Rosie. This shape has 4 sides. And all 4 sides are equal. What is this shape?
Oh, for goodness sake, it's a square!
You're correct. This is a square because it has 4 sides of equal length and 4 square corners. So this is a square. It has 4 straight sides. How about a triangle? Ooh. Let's see. There's 1, 2, and 3. 3 sides, 3 straight sides, and 3 corners. That's right. A triangle has 3 straight sides. But how about this odd-looking shape? It has a very big curve, and it's very, very sticking out, kind of.
It's very sticking out.
Yeah, the boundary is. It doesn't.
Boundary?
It doesn't appear to be.
It's a boundary.
It's a boundary. It doesn't
It's a
appear.
boundary!
Ah,
Okay. Is a boundary a place?
kind of.
What kind of place? Okay! I was joking on that one.
Okay. Anyways, this shape does not appear to be straight at all. This does not appear to have sides at all. But what kind of shape is it?
What's the side? Okay! Okay, I get it. I'm sorry, I was being too silly.
It's okay.
Okay!
Let's see. It has 1 curve.
What's a curve? Okay!
And it doesn't have any corners. I don't see any corners around this shape. No corners. It doesn't even appear to have a side at all. It's completely round, though. What's a shape that's round? Oh, I know.
Oh, finally!
It's a circle.
Finally!
That's right. A circle is a shape that has no corners and no straight sides. So there are 0 straight sides in a circle, but it does have 1 curved edge that is completely round. Like, take, for example, a coin. A golden coin.
That's ugly?
No. A coin is a circle.
Especially that.
Kind of, yeah, I agree with you, but...
It looks like you. Oh, yeah!
Okay,
I was joking.
okay, anyways. A coin, for example...
Sorry.
For example, a coin is a circle.
Sorry.
For example, a coin is a circle because it has 1 curved edge as well.
Ow! Yes?
Are you done now?
Sorry. I just need to cough. Okay, I'm done.
Okay. Anyways, just like a circle, a coin...
I'm done.
Okay. A coin has 1 curved edge that is completely round, and the coin doesn't have any corners. And if you keep tilting it and tilting it and tilting it and tilting it around and around again, it does not appear different to you, does it? Nah, it's the same shape every time. So, it's completely round. But that does not mean that it is not a shape. Be careful. Although some shapes are supposed to have straight sides, like polygons, which are shapes that are supposed to have straight sides that do not curve and do not intersect each other, in which case a circle is not a polygon, a circle is still a kind of shape because it is closed and it has an edge. So it's a shape. A circle is a shape. And in case you were wondering, a shape is a figure that may or may not have sides. What was that?
Why are you on my roof?
Uh-oh. Ouch! Sorry. I'm very sorry. So yeah, this coin is an excellent example of what a circle looks like.
A circle is in a very specific category of shapes.
A very specific category of shapes. Because, unlike any other shape which has sides, a circle doesn't even have any sides.
So anyways, can we move on?
Yes. Anyways, we can move on. A coin is an excellent example of a circle. And now, we get to this shape. Wait a second. This shape has 4 sides just like that one. But they all look different. Exactly. These sides are of different lengths, which means that this is not a square. Be very careful here. This is actually a rectangle because it has 2 long sides and 2 short ones. And it does have 4 corners like a square does. So a rectangle also has 4 corners. Basically, any 4-sided shape has 4 corners in it. Look at each shape. Write the number of corners. Oh. I started too early. A rectangle has 4 straight sides, and a square also has 4 straight sides. A square and a rectangle both have 4 straight sides. A square has 4 straight sides, a rectangle has 4 straight sides, a circle has none, and a triangle has 3. And corners, a circle doesn't have any corners, because we just mentioned it. If you look around and around and around, very dizzy. You can't see any corners there. I mean, are there any points there? I don't think so. So no corners. No corners here. However, when we look over here, this is a square. And it's a 4-sided shape. Which means that it has... You could go ahead. No, it's not because it's a triangle. This is a square. Does this have 3 sides to you?
Okay, that's it. Vicky, you have one more question to answer.
No, it doesn't have no corners at all.
Vicky, go sit down.
Good try, Vicky. But this shape actually does have corners. Can anybody else?
What are we doing?
Answering the question, how many corners does a square have?
Oh.
Anybody else want to take a turn? Yes, alligator? Finally, someone respects my name.
It's called a nickname.
Well, I hate that nickname so much.
Gator.
I am alligator. Let's see. There are 1, 2, 3, 4 points on the square. And points are corners, right? Yes. But it has 4 sides, so it means it has 4 corners, right? That's right. Because like I said before, any 4-sided shape has 4 corners. They don't have to be square corners. Square corners are corners that, when you trace them, are shaped like a square. Or, sorry, not trace, draw them or put them into detail. Look how I'm drawing it. What is that thing? Yeah. Ouch.
You just imagine things.
Yeah, you're right. Now, anyways, yes, a square has 4 corners. And this, 2 long sides and 2 short sides, is a rectangle, which means that it also has 4 corners. Squares and rectangles may look different at first glance because we could tell the difference between them, but a square is actually no exception. In fact, every square is a special kind of rectangle that has 4 sides of equal length and 4 equal square corners. But not all rectangles are squares. Some rectangles have 2 long sides and 2 short sides, making the sides of different lengths instead of equal lengths. So all squares are rectangles, but not all rectangles are squares necessarily.
And that's a popular phrase or saying you might have heard.
Yes, that is a very popular phrase in geometry and mathematics that you may or may not have heard before. All squares are rectangles, but not all rectangles are squares. So, fun fact for you. And obviously, what is this shape? A triangle, of course. And a triangle has 3 corners because it has 3 sides. 1, 2, 3. 3 corners. So it has 3 corners. Ring the shape that has 4 sides of equal length. Okay, I think we should all know this one, right? From experience, which is the shape that has 4 sides of equal length. Yes?
Oh my goodness, why did you raise your hand?
I'm trying to answer it, okay? Chill down. Square! That's right! A square is a shape that has 4 sides of equal length. Well done! And now, that was just a warm-up.
Oh no.
A small warm-up, a very tiny one. Now, we're leaping farther. Now we're getting into the deeper concept of shapes, which you may or may not understand, but should be easy enough once you get the hang of it. There are 2 kinds of shape categories, flat shapes and solid shapes, or as I like to call them, 2D shapes and 3D shapes. Just like Fries' house. Look at it, it's a 3D shape.
But my stepping stones are 2D shapes.
Yes, because they are flat. But this is not flat. This is solid. See? Think about the 3 states of matter, for instance. Solid kind of reminds you of an ice cube, right? A solid state of matter. And a solid shape, if you look at one of those solid shapes, it looks like a cube. So, it could remind you of an ice cube. One of the 3 stages of matter could look like a 3D shape. An example of a 3D shape is a Rubik's Cube. You may or may not have heard of these toys before. Yeah, how do you solve them? Well, I'm not going to show you how to solve them because it's too complicated. So, sorry, 2 laughs. Anyways, so, we are going to introduce to you the difference between flat and solid shapes. Flat shapes are known as 2-dimensional shapes because they only have 2 dimensions, as their name suggests. Length and width, width and height, or height and length. It just has to have 2 dimensions, that's all. So, any shape that is flat can be 2-dimensional. Ring the flat shapes. Okay, what are all the flat shapes here? Let's try to identify all the flat shapes. Which shapes look flat to you? We could use a couple of these shapes to help, including the coin, which I find very useful.
I think I know what shapes are flat.
Which shapes are flat?
Oh, let me get out of my house.
Your 3D house?
Yes, it's so cool. I have a door. Click, click.
Yeah. Just think of it, a door is a solid too, so, solid shapes. Wowza.
Well, if I look at the coin, I see like it's round and it's flat, and I know, even though this and this and this looks round, it's not two-dimensional.
That's right. These shapes are not flat. They appear to be solid and sticking out the top. Just like your house. You see? That sticks out the top and it's solid.
But what I do notice is that this coin represents this shape and this shape.
You're right. A coin represents a round shape, which is a circle.
But one thing I got confused by was this. But I knew it wasn't a circle because of these lines.
Yes. This line is pretty difficult for you to know. This line is actually known as, if you think of the planet Earth, this line is what I like to call the equator of the sphere, or the entire
Middle.
The entire center of the sphere, the entire middle. So, this may look like a circle to you, but it's actually not a circle. This is a sphere. It's a 3D representation of a circle, but is not a circle.
Now, the next thing I did was I took this square.
Yes, that's a square. Good job.
And I looked for any matches. I noticed this looked like a square, but it had other faces on it.
That's right. A face is any flat surface on a 3D shape.
And so did this one, so I also knew not to look at that one.
Yeah.
So I took my square and I noticed that this looks like it and this one.
Yeah.
But then I found something particular. This looked like my square, but it wasn't. And I realized that it was a rectangle because these two had the same length and these two had the same length, but they all together were not the same length.
That's right. So only both pairs of opposite sides are equal. And two pairs of what I like to call closest next door neighbor sides. Hi, hello. Next door neighbor sides, as the name suggests, are next door neighbors, kind of. So both pairs of next door neighbor sides, like this, are not equal because they're of different lengths. So yes, circles, squares, and rectangles are all flat. Can you name two more flat shapes?
Actually, I can name 3 more.
3 more? Ah.
Okay, so first thing I did was I took my triangle and I looked around, and when I saw these two, they looked like triangles, but number 1, they were more rounded, and number 2, I already know from the coin that they had an extra face on them.
That's right. These are called cones, and cones have a circular base. So although they look like triangles, they are just a 3D representation of triangles. Another representation is the pyramid.
But what I did notice was that these two both look like triangles. And now I have one more shape.
What is that shape?
Well, I looked around and I noticed this shape.
What do you notice about this shape over here?
We have not seen it before.
That's right. We have not seen this shape before.
It has 6 sides,
That's right. It has 6 sides.
and although it does look irregular, because it does not have any other faces, it's technically a 2D shape.
Yes, so it's a flat shape.
Yes.
This shape is actually known as a hexagon. And a hexagon is a 6-sided shape. Now watch this magic trick I'm going to do.
Oh no.
It does not look like a hexagon to you. But just hold that thought. Just wait just a second. And voila. You get a hexagon made out of triangles.
1, 2, 3, 4, 5, 6. It has 6 sides.
Yes, and that looks completely flat. So, this is a hexagon, or a shape, with 6 sides and 6 corners. Looks like we learned a new shape.
Now, anyways, let's continue.
But what about all these other shapes?
Well, these must be 3-dimensional because I know from my house that if I took my door, I took off my door, I looked at my door, and I looked at this and I said it's three-dimensional, that wouldn't be right because it's only one face. But if I closed my door and I looked at my house, I would think, well, that must be three-dimensional because even if we only saw two of the sides of my house, you would know it's three-dimensional because it would have multiple faces.
That's right! It is three-dimensional because it has a lot of faces in most shapes, but not in all shapes. Like the sphere, for example. Spheres do not have any faces at all.
But I noticed in all of them, except the sphere, obviously, that they had multiple faces.
Yes!
For the sphere case, however, I would notice how there's a line in the middle and a dotted line inside the shape that is saying that there's a line around the sphere.
That's right! A dotted line signals that the straight line is not only present at the front, but is also present at the back. So the line, or the invisible equator, what I like to call it, must appear everywhere in the sphere, or the center.
Yes, and because I know this, that's how I would know that this isn't just a regular coin, this is actually a sphere.
That's right! And a sphere is a 3D circle. Let me show you a very great example of a sphere that I would like for you to know. Wow! Wow. Ow. It's kind of hard to bounce on a ball, is it? A ball is a perfect example of a sphere. Because as you notice, no matter how hard we try,
Goodness.
we can't flatten the ball. We cannot flatten the ball unless we deflate it or pop it or something. But anyways, you see where I'm going with this. And ow, feels very solid. Ow, very tough. So, this is a very good example of a sphere. And although you don't see the center lines of the sphere, those are just invisible. So, it's still there, but you don't see it. So, this is the invisible center line that appears in the sphere.
How many more pages?
Don't worry. We have, let's see, a couple more. Like six left.
Oh, no.
6 pages left. Do not worry about it.
Alright, can I have my ball back?
Yes, you could have your ball back. Catch.
I'm going to my house now.
Yes. And this 3D shape has a square on every face. No, wait, actually...
Yes, it does.
Wait, really?
Yeah. Those invisible lines are just indicating that the faces are there.
Oh, I forgot. I must say, you must really be a shape expert. This...
Yeah, I really am a shape expert. I've been waiting for this lesson for like 20 years now.
Yes. This is a cube because it has all faces squares. A good example is a Rubik's Cube, which has all different kinds of vibrant colors. Ooh, interesting. Nice. Yes, but no matter which color the cube is, it's still a cube because color does not affect its shape. That would be very silly if it did. So, yes.
Imagine studying for a geometry test and you had to remember what color each of these little cubes was because they were all completely different shapes.
Yes, and if you look very closely over here, you can not only see one cube, but every square must have 3 dimensions. So every square that is making up this Rubik's Cube is an actual cube. 1, 2, 3, 3 dimensions. There's length, width, and height. Length, width, and height. 3 dimensions. All together make a 3D or solid shape.
Can we move on now?
Yes. Although it doesn't look like a cube, it is a cube. But sometimes it is pretty difficult to make an exact cube. These are rectangular faces, but we must all remember this is an approximation of the cube. So it's not exactly, but you see where I'm going with this. A cube has 6 square faces.
As you can see, my lovely house.
Yes. Fry's bottom portion of her lovely house kind of looks like a cube from underneath. But at the top, we see lots of triangles meeting at a single point.
However, if I did take off my roof and I placed this instead,
And attach a square roof.
then I would be inside a cube.
Yes! A cube has 6 square faces. However, this is not necessarily a cube.
Amar, just get off!
Sorry. Well, anyways. However, this is not actually a cube because it has an oblong rectangle for all of its faces. I'm not saying that this is not a cube too. This is a cube. Just an approximation of it. Some people have a very hard time approximating cubes. This is a cube, but this is not a cube because we could visually see that there are oblong rectangles. Oblong rectangles are any rectangles that are not squares. And, anyways, so
Let's move on.
this shape is known as a rectangular prism because it has 2 rectangular bases
I think you're getting a bit more out of the kindergarten zone.
and 4 rectangular lateral faces. Yeah, I am, but prisms aren't too complicated, right?
Well,
Let's make the
no,
shape.
whoa.
Fine, I won't make the shape. Okay,
Let's move on to the next page. We'll have 6 more pages to go.
forget about it. Anyways, this is a cylinder with 2 circular bases. This is also a cylinder. This is a cone with a triangular-like body, and then a circular base. And this is also a cone. And this is a sphere. Okay, moving on to next page. Where's the pen? Oh, there it is. Now, this page talks even more about cubes, about how many faces and sides and edges it has. Let's make a cube. So, if we look over here on one of its faces, there are 4 sides of equal length. And if we double check to see if that is true, this square is exactly like this one. So, the faces are shaped like squares. The name of the shape is the square. And how many faces? Well, it's slightly difficult to determine, but it should not be too difficult. You just put the square on every face possible. Look, 1, but then this becomes 2, 3, 4, 5, 6. There are 6 total faces.
Can I say something?
Yes, you could say something. Come on, go out of your house.
I have little plans. Anyways, you might be wondering, how come when I move the square from here to here, why is it a different shape? Why does it look different? It's because you're at a different angle.
You're at a different angle. So this is not an oblong rectangle. This is indeed a square, but just at a different angle. So that's why approximations of the cube have been drawn.
Yeah, that's all I want to say.
Yes, that's all you wanted to say. Anyways, now a cube has a lot of corners. I could tell you, a lot of corners. So let's count the corners. There are 1, 2, 3, 4, 5, 6, 7, and 8. And those are all the corners because these must be the corners of this, and this. So these faces. So 1, 2, 3, 4, 5, 6, 7, 8.
9.
Where do you see a 9th
I
corner?
was kidding!
Of course you were kidding. You better be kidding. Cubes have 8 corners. And cubes are actually special kinds of rectangular prisms. That have all faces, squares, and equal. We get it! Okay, sheesh. Sorry, I won't mention rectangular prisms anymore. What is it? What is it? What is it? What is it?
What are you freaking out about?
I'm sorry. Now, if you look at now if you look at Okay, sheesh. One side of a cube is known as its edge. And there are lots of edges in a cube. Let's count all the edges together. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Oh, yeah. There are 12 edges in a cube. 12 equal sides. Because all of the faces are squares, and all squares have equal sides. So guess what? All the sides or edges of the cube are equal, which makes all the corners equal, which makes the whole cube pretty much equal. A cube is a 3D square, just to clarify. Now, you could also use prepositions to describe the locations of shapes. For example, the cube is below the sphere would be of this picture, because this is a cube. It appears to be a square, but this is a sphere because it appears to be a circle. The cube is below the sphere. Then, the cube is in front of the cylinder would be this, because this is a cylinder and that's a cube. The cube is above the cone, like this, cone, cube. And the large cube is behind the small cube. Yes, this is a large cube and this is a small cube, depending on the sizes. But we need to know what the rest of these 3D shapes are. What even are cones or cylinders or whatever? Look at each shape. Write the number of faces that it has. A cone. A cone is a little tricky. Look very carefully. Just think, how many surfaces does this cone have in the first place? Can anyone take a guess? How many surfaces does a cone have? Okay, you could go. Beep. Beep. No, not one, but, good guess, though, actually. Take another guess. No, it does not have 0 surfaces, but, very great try. One more? No, not 3, but, good try. I'm sorry, Becky, go back to your seat. No. Stop crying on top of a bunny. Cones actually have 2 faces. 2? How is that even possible? We only see one circle visible. Yes, but what you're forgetting is cones have surfaces, and any surface on a 3D shape could serve as a face. It could not always serve as a face, but it could serve as a face. Indeedly, I just learned that today. Cones have 2 faces. It has this circular base we all should know of, but it also has this weird triangle-shaped body. So, this triangle-shaped body can be thought of as an extra face. So 1 plus 1 is 2. There are 2 faces of a cone. Cones have 2 faces. And a sphere, as we mentioned before, has no faces at all. So 0. 0 faces. A cube has 6 faces. 1, 2, 3, 4, 5, 6. And a cylinder. How about a cylinder? Anyone else? Me! Oh yes, Apricot, we didn't even get to you today. That's okay, I was not even introduced on the video yet. Let's see. It's kind of a tricky one. Okay, there's one circular base and another one, which makes 2. But there's this oddly shaped body over here. Wait a second. That serves as a face. Because if we were to try to make this shape, that's it. That does it. This oddly shaped body could simply be just a bent rectangle to make 2 circles for the 2 bases to fit in, which serves as an extra face because rectangles are flat. So I say 3 faces. That's correct! Cylinders have 3 faces in total. And you're gonna love this one. It's called stack and roll. Stack and roll? What's stacking? That's a very great question. When you stack something on top of another, you basically put things on top of another. That's it. That's what stacking is. See? This is an example of stacking because I just put all of those on top. Fine, here's your plant. Oh, sorry, that's not your plant. That's not your plant.
By the way, that wasn't my plant. I was crying because I wanted the shape.
Oh, okay.
You go, though.
Okay, thank you. However, rolling is a little different because it not only rotates, but also contains a movement. Look at this. This is rolling. Yes.
How many more pages?
Just a couple more. Sheesh, chill down.
How many?
3.
Okay.
Okay. So, this is rolling, and this is stacking.
Sorry, I got hungry.
This is stacking. A dinosaur!
What are you talking about? There's no dinosaurs here. Look around.
Yeah? You're right. It's probably nothing.
Just start.
Fine, teach. This is stacking, and this is rolling. Some 3D shapes could do both, but other 3D shapes can only do one action. So this is a cube. Let's build a cube and see if it could stack anything. Excuse me, I'm sorry. Need to destroy your house for a second. Fries, you're experiencing a major crisis over here. Breaking apart your house. Are you leaving this for me?
Huh? Sorry, I was sleeping.
Let's make a cube.
What's a cube?
Ah.
Wait, you're trying to fly out my house!
That's what I said to you. You didn't listen to me.
Fine.
This may not look like a cube, and it's not. It's a cross. But if we fold the squares up together, this makes a wall. And once we form these together, that makes a wall. And the 2 walls connect, leaving room for 1 more square. That is a cube. Okay, this time we're going to do 2 tests of something I like to call experiments. You might have heard of the word experiment in science class before. Or not, depending on what your science technically is. So, this is a cube.
What's a cube?
Let's see if it could stack things. Let's take this Rubik's Cube and put it on top of this colorful cube. It stacks! That's right! Cubes stack. But does it pass the second test? Let's see if it rolls. It's not really rolly. It's kind of hard to roll it. Ow! Nope. Cubes don't roll. So, cubes could only stack things, not roll. However, the sphere is completely different. Let's look at the sphere. Does it pass the first test? Stacking! Huh? Oh my goodness! It's almost like the little ball is invincible. 2 powers. 2 undefeatable powers. Yes, spheres do not stack things. However, what we do know is that spheres roll like this, just like how a ball rolls, and a ball is a sphere. So, cubes only stack, and spheres only roll. But how about a cylinder? A cylinder. Cylinder is a very interesting
cylinder.
shape. We don't have a cylinder, but if we look into the faces here, they are flat. Let's see if it passes the first test. Stacking. Okay, so what we know about flat faces is that they are very good at stacking things. So let's just see if this circle, which is one of the bases of the cylinder, could stack. Could stack this. Well, circles in general alone do not stack, but the circular faces of the cylinder do stack. So, yep. But does it pass the second test? Let's see if it rolls. That was one of the circular bases. But since the circular bases help it to roll and rotate, this long and elongated body helps it to roll further. So guess what? Cylinders can both stack and roll. Wow. Very unique. Yes, exactly. So cubes are only able to stack, spheres are only able to roll, and cylinders can both stack and roll. This is an optional but a very fun DIY project if you want to make a cube. Step 1. Use clay to form 4 spheres as shown. Step 2. Use 4 straws to connect the spheres of clay. Step 3. Repeat.
Clay?
Yeah. Repeat step.
Clay?
Clay.
Clay?
Clay.
Clay?
Clay.
Clay?
Clay!
Okay, what's clay?
Oh, clay is a very soft material that could turn...
What's the material?
Anyways.
I'm good!
Okay, we're finishing up. Step 3, repeat step 1 and step 2 to make another square. Step 4, use 4 more straws to connect the squares to form a cube. This is what it should look like when it's done. Very nice. Very interesting. Someone even drew one. Okay, we're coming down to the last 2 pages. So, look at all of this stuff. There's a jack-in-the-box over there. Circle the object shaped like cubes on the top shelf. Circle the object shaped like cylinders on the middle shelf. And circle the object shaped like spheres on the bottom shelf. Which objects are shaped like cubes? Let's see over here. This tissue box has 3 faces shown, but if we theoretically turn at a different angle and look at its edges, this face must also exist here. Front and back, left and right, top and bottom. 2 plus 2 is 4, and 4 plus 2 is 6. 6 square faces. So yes, the tissue box is a cube. And the jack in the box is a cube. But, guys, I do not see how this could be a cube at all. Look at it. It's just a simple line.
Can I have my house back, please?
Yes, you could have your house back. Here you go. Oh, sorry. Squares. Okay, you can have your house back. Now you can build it.
Thank you.
Anyways, yes. On the top shelf...
How many more pages?
2.
Okay.
On the top shelf, there... I just...
Sorry, I'm tired.
It's okay. It's okay. Everybody gets tired. Anyways, on the top shelf...
What shelf? Yeah, this.
Yeah, that'd be great, but, are you sure you don't need this for your house?
No. Also, do you want these?
Yeah. Okay. We'll save those for later. Anyways, on the top shelf, the tissue box and the jack in the box are the only cubes around here, and the pencil, it does not even look close to a cube. I mean, come on. If anything, it's not a 3D shape at all. It's just a line. By the way, a line is a one-dimensional shape. A one-dimensional shape? Yes, a line could be a shape with only one dimension, which is obviously length, or how long it is. This is a one-dimensional shape, but we're not going to talk about those, because I think they are too simple. Just think about it. Tissue box. Jack in the Box. Boxes kind of look like cubes. This Rubik's Cube, for example, kind of looks like a very tight box. And especially the bottom view of Fries' house. I love it. It's all boxed in, get it?
What's a house? What's a house? What's a house?
I don't know how you're even building this house.
I can tell you.
Okay. The objects that look like cylinders. It's a thing.
What's a thing?
You know, a thing.
What's a thing?
An object. The objects that look like cylinders on the middle shelf are this object and this object. But the reading book is a rectangular prism. Not rectangular prisms. Okay, fine. We'll just say that this book is not a cylinder at all. So, the reading book is not a cylinder, but these two are cylinders. And the things that look like spheres on the very bottom shelf are the beach ball and the orange. It doesn't matter if they are different sizes or if they are different ways round. All that matters is one curved edge, no faces, and no corners. Make a sphere. And the notebook is not round at all. It's rectangular. So, the pencil, the reading book, and the notebook are the only three shapes that do not belong. However, the tissue box, Jack in the Box, this and this, I don't know what these are, and the beach ball and the orange are the shapes that belong. So basically, a cylinder can be thought of as a special kind of prism that has two circular bases. And a cone could be thought of as a special kind of pyramid with a circular base. Do you ever see the Great Pyramids of Egypt? They are shaped like pyramids, as the geometric name suggests. So, if we take apart... Oh, wait, sorry, I have my own shapes. Never mind, sorry. If we do this... Sorry, I just need one last one. One last one, I promise. One last one, I promise. We connect these together... They are like the cube, but this time the triangles are the faces instead of the squares. This makes a triangular solid or 3D shape where all of the triangular faces touch at a certain point, and the square is the bottom of it. I'm just viewing it at different angles so that you could get a good point of what a pyramid should look like. Do you ever see the Great Pyramids of Egypt? They're shaped exactly like that, except with different detail. And if you form 4 triangles together, this also makes a pyramid. Just with all triangles this time. Anyways, enough about pyramids and prisms anyway. A cone is a special kind of pyramid with a circular base. So, color each kind of shape according to the color of the shape shown. Let's see over here. Don't worry, this is the last page, I promise you. Coloring in 3-dimensional shapes. Cylinder, 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 cylinder. I see 4 cylinders. What is the color of the cylinder?
Cylinder?
Red. No, wait, scarlet. No, red. Wait, scarlet. No, wait.
What's a cylinder?
Red.
What's a cylinder?
It's a 3D shape with 2 circular bases. And yes, this is red. The cylinder is red. So, we color all the cylinders red. And we see 1, 2 cones. What is the color of this cone? Yellow? That's right. The cone is yellow. So we color these 2 cones. So we color the cones, coloring the cones yellow. And we see 1, 2, 3 cubes. What is the color of the cube?
What's a cube?
It's a three-dimensional
What's the shape?
shape with 6 square bases.
What's the square? What's the basis?
It's green, right?
What's green?
It's a color.
Oh, what's the color?
Yeah! That's right, the cube is green. So we color all 3 cubes green. So we color the cubes green. Okay, so far, we color the cylinders red. We color the cones yellow. We color the cubes green. And we see only one sphere. What is the color of the sphere? Blue? That's right, the sphere is blue. So we color the sphere blue. So, in conclusion, we color the cylinders. We color 4 cylinders.
How many more pages?
I'm getting to the end right now, actually. This is the last page.
Uh,
We are coloring 4... Not our coloring, sorry. We colored 4 cylinders. We colored 4 cylinders red.
my house!
Anyways, we colored 4 cylinders red, 2 cones yellow, 3 cubes green, and 1 sphere blue. So, colors and shapes could really help you a lot, especially with these shapes. Alright, that is it from us today. I hope you learned a lot about flat and solid shapes, and 2D and 3D shapes. 3D shapes are solid shapes, and 2D shapes are flat shapes. Bye, everyone! Huh?
My house!